Streaming live via the internet, welcome to ISP Radio, your weekly source for ISP-related news, events, and interviews with industry experts. If you deliver internet via fiber optic, fixed wireless, coax, or any other way, you're in the right place. And now a brief word from our sponsors. Link Technologies Incorporated provides the lowest priced Microtech products in North America, as well as Wade Towers, Mimosa, Cambium, Ubiquity, Nettonics, and a host of other products and services to be your one-stop shop for your ISP needs. Visit www.linktechs.net. That's LINKTECHS.net for more information. TowerCoverage.com, providing online RF coverage maps with website integration. Stop rolling your trucks for every site survey and start doing installations. Visit www.towercoverage.com now. And now we'd like to present our hosts, Steve Graybiel and Dennis Burgess.
Welcome to another edition of ISP Radio. I'm your host, Steve Graybiel, broadcasting my part of the show from Moriarty, New Mexico in my office, and Dennis Burgess is producing and co-hosting the show from St. Louis. Dennis, you there?
Yes, sir. Yes, sir.
Any good news on the horizon? It's been pretty boring out here. It's been so slow. Not a lot of sign-ups or stuff, but out here I've been able to focus in on fixing all of my equipment. Been welding on the fiber plow and painted my truck that's been deficient of paint for about 12 years now. And we actually stripped down one of my older plows that I got and painted it. It looks brand new. So it's kind of slow for the wireless business and the fiber business, but I'll take those slow times as they come to be productive to fix things. Anything going on in your neck of the woods?
Well, we've been busy. Obviously, we have still have plenty of the Microtech exploits going on. That's definitely been a big issue for a lot of WISPs. Microtech has fixed it, but the big thing, for whatever reason, we've had a lot of customers that we say, okay, all of your username and passwords have been compromised. They're probably in their lists. So now they're going to attempt to use those username and passwords to get in, and they don't change them. So even though we have blocked the hack, the issue is that now they still have a username and password that is an admin that is, in full control of that router, and they don't want to lock down the router fully. So because of that, of course, then they get hacked again. Then we actually find we've recently started a new trend with these hacks where they are actually going in and actually changing the administrator password or the admin password. They're removing other service accounts. So basically the only thing we have, or the only ability that we have, is to do a net install of the router because we have lost all management access. We have lost all access to the device. So hopefully you have a backup. I would highly recommend getting backups. Make sure that your backups are working. It is definitely something that you need to make sure of. Furthermore, I would really highly recommend putting a employee. So if you have your backups going to Gmail or an email account, make sure that you have someone checking on that at least on a weekly basis. Make sure that they actually are doing their job and make sure that they are checking that, hey, we did get a backup from every device that is critical to our infrastructure. Because otherwise, we can restore things, but we actually just had a customer a while back that they had a CCR die. They took another one up there to replace it, and they're like, well, half the stuff don't work. Well, we never have a backup for it. They had scheduled a backup, but changes in their mail system caused that to fail, and they never noticed it. So, again, we eventually restored from an older backup and then updated it, which is fine, but you just need to make sure that your backups are working correctly, and it needs to be done at least on a weekly basis. I know our backups run every night. I get email notifications. One of the very first things I do every morning is check my folder and say, did my backups run? Yes, they did. Great. All's good. But if you don't sit there and check that, then you become complacent you think they're working, and then whenever you need them, they are not there.
Right. Well, that brings up our guests today. We kind of had to add
Addition.
in addition to the show. Thank you, Dennis. We got John Brown and Tasos Alexiou with RF Elements, and John Brown with CityLink Fiber. And John just recently informed me, because I'm a customer of his, that I got to start looking into my Microtech infrastructure and start doing some things. And I talked to him earlier today, and he says, yeah, these are the things you got to do. And what you mentioned, Dennis, is imperative. But fortunately, John Brown has a couple of them that he told me are compromised. So I'm going to turn this over briefly to John to talk about what has happened to him, what he's doing, and the steps we as ISPs can do, like you say, do backups and change passwords and the like. There's a little bit more to that, as I understand it, that we can be doing proactively to protect our infrastructure. So, John, are you there?
Yeah, good morning. I'm here. How are you today?
Great. So tell us a little bit about what's going on in that CityLink.
Yeah, so, CityLink has expanded. We're, in fact, getting ready to turn up our first commercial customer in London, United Kingdom. So our network is now transnational. We've got equipment in the UK, and we're operating as an ISP and hosting company over there. We're also in the process of becoming a ICANN accredited domain registrar, and we've got some really exciting news coming out about that, where we're going to talk about some things that we're going to do for the WISPA community on pricing for domain registration and security of domain registration and things along those lines. Spent a week ago doing a training at the Council of Europe in Strasbourg, France. Beautiful building on cybersecurity. And then I was also earlier this summer in Kuala Lumpur at the FIRST, which is the Forum of Incident Response and Security Teams, which I'm a member of, annual meeting, doing some training and presenting on cases there. But Microtech, in these various events that I go to on global cybersecurity, Microtech gets a lot of sort of a bad name, if you will, from people, and it's just really not quite fair. And when it comes down to it, as Dennis said a few minutes ago, network operators have got to do the right things about protecting their network. And I think one of the things that I take away is that many people don't understand that the sophisticated cyber criminal organizations today, they're almost as good as like our NSA and big data, right? They're collecting huge amounts of information on us, and they're squirreling it away in databases, and then they trade and sell that information back and forth. Just as we're the product for lots of social media companies like Facebook and LinkedIn and so forth, our data is also sold and bought and traded in the underground communities. And so, earlier this year in April, Dennis did a presentation, a little 8-minute video on the Winbox bug that was in Microtech. And people need to get out there and update their stuff and then change their password. Well, what's happened is earlier this year, lots of people had their Microtech scanned. I can go into my NetFlow data and see tons of Winbox traffic. They had their network scanned. Their user database was downloaded because of the compromise issue, which Microtech as a company promptly and timely fixed. And they always seem to be very good about fixing that. And so they got that fixed, but now what we're seeing is that username password combo has been taken, sold, traded, whatever, and is now being pushed back out, and hackers are going out compromising boxes with these credentials. Why? Because network operators are lazy. And, this is not a spectator sport. This isn't something you can sit on a sideline and just watch and hope that it all works. Operators need to stay up to date on their code. They need to stay up to date on best practices. And like Dennis was also just mentioning, change management. You've got to make sure you've got valid backups. Not just do you have a backup, but do you know what has changed in your code and why? I use an open source product called Libre NMS that uses and ties into another piece of software called Oxidize, which downloads every 5 minutes all of my MikroTik and Juniper and Cisco router configs, puts them into Subversion, which is a change management revision software, revision control system, and I can go pull a config difference between the router change I did last week and the router change I did a year ago. So one thing, getting downloads or backups are great, but do you know what has changed in your config? Today, in the last couple of days, I've been tracking some hackers that have compromised some CCRs. And these are CCRs that I've put out as honeypots to see what folks are doing to their ticks and what the hackers are doing. And what we've seen is that these actors are doing really clever stuff now with the programming capability of a MikroTik. So, for example, they're setting up IP socks, which is an ability to allow you to tunnel through a MikroTik and use the MikroTik as a relay to attack somebody else. That's what the SOX protocol does. Doubt most ISPs need to be running the SOX service. They need to make sure it gets turned off. I look at this tick config and I also see that they're setting up a bunch of scheduler under system scheduler where the system runs scripts in the background. And some of those scripts change the logging so you don't see syslog events for things that happen. They're reaching out to certain websites and pulling down a mikrotik.php file, or they're pulling down another file, and then they're using a /import of that file, which is basically a config script, which causes it to re-change the configuration. So, hey, you log into your MikroTik, oh, that's not supposed to be there. You make a change, and then 5 minutes later, that change goes away because this script is running in the background, re-updating the MikroTik to make sure it stays hacked. I'm also seeing where in this one MikroTik that we have that got compromised, that's a honeypot we set up, they're using it to actually set up port sniffing. So they're doing traffic and port monitoring and doing /tool sniffer. This allows the MikroTik, the hacker, to grab all of your traffic and export that somewhere else in the world for later analysis. So they can sit there, pull all your packets out, stream everything that goes across the network, and then come back later and look at that traffic and try to determine if there's other vulnerabilities or other things in there that they should be using to hack. I see a script in here where they're using Tool Netwatch, and they're setting it up where they go out every couple of minutes and they're downloading another file. It's an innocuous file. It's called autosupout.rif. All of us in the MikroTik community have seen and heard that file, but then they import that file. And that particular import of this particular file is another script that runs that changes the configuration of the MikroTik. By using a common name that we are all used to seeing in our MikroTik under /file, it helps sort of obfuscate what's going on. So the takeaway here is MikroTik themselves stay up to date really good as a company to have good versions of code out there. We as network operators have got to start investing the time to make sure that we keep our devices up to date. We've got to make sure that we've changed our passwords. I can't stress this enough. I mean, if I had to clip up, I'd ask Dennis to play the video right now. It's the little YouTube clip from Spaceballs where it's the luggage password. And if anybody out there, I mean, just search for that and you'll know what I mean, right? The password for the luggage is 1, 2, 3, 4, 5. Really, guys and gals that are running networks, get your password changed, change them on a regular basis. You've got to upgrade to the current version of MikroTik software and then change your password. But more importantly, know your device, go through it. Make sure you turn off all of the vulnerabilities. Don't just turn off one thing or two things and think you're safe. You need to know exactly what that box is doing and what things should be turned off. You need to know what scripts are in your ticks. I bet you there's at least 50% of the folks watching today that if you went in and you did flash system space scripts export, there are dozens of scripts in there you don't use anymore and haven't used in months or years. Why are they there? Get rid of the dust bunnies in your configuration. It's down to the hackers are serious. With millions of devices out there, the ability to compromise these not only affects the user, it affects the operator, the network operator, because it sucks up your precious bandwidth. It also damages your reputation to your customer in the community, and it damages your reputation with respect to your IP addresses and your domain names within the InfoSec community. So this is where you get the people bitching about the fact that they are now on some block list. Well, your MikroTik got compromised, and it got used to push spam through it, which is why all of a sudden you're on Spam House. And now it's going to take you a week of time back and forth to get off of that. You do have a time. I mean, Steve, you're a network operator. How busy are you, to all of a sudden insert, oh, now I got to go clean up a dozen MikroTiks. Well, scale that out. I got to go clean up 3,000 MikroTiks. Anyway, cybersecurity and network security, as we go about making the network more secure, network hygiene is more and more important. We don't want stinky neighbors on the network, and that means stinky network operators. So we've got to work together as a community to clean up and make sure we run best practices. And honestly, if you don't know what you need to do to make your network cleaner, or you don't really understand, then go hire somebody like Lynx Technology, Dennis's company, or others that are out there that have those skills to do that and are able to help you build a plan. But even if you do hire a consulting firm to help you with your network, at the end of the day, it's your network. You've got to know what's going on in your network, and you've got to make sure your employees follow what your change management practices are. So I'm going to get off my soapbox now, and questions or comments or what.
Well, I got a question as an operator using MikroTik, and this is for Dennis and John, being that you're both MikroTik gurus. We talk about best practices. You talked about backing up and changing passwords. What are some of the other things? I know blocking IP services, that's helpful. Dennis uses a firewall block. What are some of the other things out there that we as MikroTik users can do to mitigate people getting to our routers? I'm going to leave that to Dennis first.
Well, the simplest thing to do is to lock down all your services. You have IP firewall, you also have IP services that you can actually sit there and specify very specific IP addresses to come from, to do and to access said services. One of the other things that John said was that some of these hackers are using port sniffers. I actually see quite a bit of API usage right now. I'm not going to mention any company names, but there are a number of companies out there that want to use the API, but the API, by default, sends the username and password of your router in clear text over the internet. So it's not really a good option if you want to keep things secure. So you have to use the API SSL to make that secure, or build a VPN or something like that. There are plenty of opportunities to secure your routers correctly. For instance, our network at Tower Coverage, that router can only be accessed by very specific IPs, very specific items, and or OpenVPN or something like that. So because of that, it's not necessarily impervious, but it is at this point in time up to date and has not been hacked. That's the goal. Is you have to know what is going on. You have to follow trade. Not necessarily presentations, but mailing lists are really good. The WISPA mailing list is really good. If you wish to use Facebook, you can. But there's plenty of documentation out there, as well as there's plenty of announcements, even from MikroTik, that, hey, these exploits are actively going on. You need to secure these. and you have to take action on those. That's about it on that.
John, industry standards.
It comes down to it's not a spectator sport. You have to stay up to date, and you have to pay attention to what's going on, and you have to read the change logs. I mean, you go to microtik.com/download, and you get the list of current versions of code up there, and then down you scroll down at the bottom, and it has the change log. Read the change log.
Yeah.
I mean, the first thing I do is I pull down a change log, and I do a word search for security, and see what are the security fixes or bug fixes that are in there. And this isn't just a MikroTik thing. I mean, let's remember back to the summer of 2017, there was a huge big hoopla about Ubiquiti and Ubiquiti radios and Ubiquiti problems. And oh my God, Ubiquiti is evil. They didn't do their stuff. No, Ubiquiti is not evil. They're a great company. You network operators that got hacked by Ubiquiti, that have Ubiquiti equipment, didn't have updated equipment software in your network. But you also have got to understand it's not just about having to update software, firmware. It's also have the right access control so that your devices aren't accessible from the public internet in the first place. You want to build a layered approach to your security. That way, if one of the layers, one of the walls breaks, whether accidentally or intentionally, you've got other layers that keep you. I mean, let's look at old medieval castles. We build it up on a high ground, we dig a moat around it, and then we build a really hard, tall stone wall on the inside of the moat that's the castle outer wall. So to attack the castle, you got to get up the hill, go across the moat, climb the stone wall, and get inside. So we can apply that same concept to what we're doing for our network devices. One of the things I tell folks to do is pick a couple of good IP addresses that are going to be your hard points that you come to the rest of your network from. And then also, if you want to access your network from the outside, build a good VPN point where you can come in from the outside, VPN in, and then get around inside your network. Another thing to keep in mind is that hackers are realizing that we're fortifying the outside of our network, and we're getting really good at that. So what they want to do is they want to figure out a way of compromising, getting inside the network, and then exploiting from the inside out, right? I mean, the Target.com Target hack was a great example of this. A guy that was setting up a controller system for their HVAC, their air conditioning system. He had to put a little machine and connect it to the network so this little computer could help control their air conditioning environment. That little computer made a phone call out across the internet to connect out to something else. Well, that little machine got hacked on the inside, and when it got hacked, it was able to build a reverse tunnel out that now allowed the hackers to get to that machine on the inside, which was not blocked by the firewall rules, right? Because it's inside, so, hey, it's got to be valid. So hackers are coming in to figure out how to get back out and how to rummage around inside the network. So your rules have got to be such that you don't trust anybody anywhere, outside or inside, unless they're coming from specific machines. You know, to use you as an example, Steve, your desktop, your network admin's desktop, your tech's desktop, your front office person's desktop, those IPs are what should be allowed to inform your devices. And then maybe specific IP from Dennis, because I know you use Link Technologies to help you with some stuff, and a VPN point. So, just food for thought.
Yep. Well, thank you for
we have more fun things to talk about today, so I'm going to shut up and just say, update your stuff and keep from having a stinky network.
Right. Well, the other part of the show, which was the main part of the show when we started off, is Tasos Alexiou with RF Elements to talk about their products, the neat stuff that they're doing. Tasos, you're there, right?
Yep, I'm here. How's it going, everybody?
Good. Glad you're back again. Tell us all about what's happening at RF Elements.
So, I mean, we have a lot of stuff going on. RF Elements continues to innovate new, interesting products. We have a lot of new products that have recently hit the market that are quite fantastic. The Ultra Dish, our parabolic dish antenna, our Ultra Horn, which is really phenomenal. It's our long-range point-to-point horn technology, and even some new adapters, a new adapter for the router board, and of course the air fiber and prism adapter that stuff on the roadmap moving forward. So we continue to innovate. We definitely continue to innovate.
Yeah. So you mentioned about a new router board enclosure. I think I bought one of the older ones. What's the cool things about the new Microtech enclosure?
Yeah, so the new Microtech, if you remember the old one was really more plastic, right? So the new one is a round, smaller form factor, full die-cast metal, so really good isolation properties for router boards and stuff like that. They keep the near-field radiation down from the board and those types of noise. So it's a little bit easier to use as well as far as connecting the internal pigtails from the board to the waveguide feed. So that's the main differences of it.
Mm-hmm. Well, I can attest to it. I bought my first horn a couple of years ago and gave it to John, and then I went and bought myself one and climbed up a tower that I could only have one. I had to have one hand on the tower. Of course, I was buckled into the tower and everything, but it was just so awkward that I had to have one hand on it. And I was able to put up the RF element horn with one hand and get it configured, not up on the tower, but get it set up on the tower with one hand. So the ease of installation is outstanding.
Yeah, I mean, that's, again, another main focus of what we do. So, of course, it's all about the RF. We want to make sure that any antenna technology that we bring to this industry is near perfect, right? As far as the flat gain across the whole spectrum. So as you change channels, you're not getting, not only lower gain at one end of the spectrum versus another, or a large delta in gain, but also the beam performance is really important. If you look at kind of the old technology, the patch array sectors that, pretty much, is the technology from yesteryear that some people are still doubling down on and still creating, that type of technology, as you change channels, the gain really differs from the low end of the spectrum to the high end of the spectrum. But the other thing that really changes is the actual beam pattern. So your coverage actually changes. So you might buy a 60 or 90 degree sector, but as you start changing channels, that beam gets actually wider or narrower. And not only it's not an overall function, but it's also per chain. So your vertical chain might actually get wider, and your horizontal might get more narrow. So that's how you get those chain imbalances, where you start getting to the edge of the sector and stuff, where horns are extremely, extremely stable, not only from a frequency response standpoint, but also from a coverage area standpoint. So it's really a huge innovation for this industry, and people are catching on. So to go beyond that, right? So the RF part, of course, is performance. That's what we're known for. But we also look at the user experience, right? The user experience is important, what the climbers think about. And if you look at a lot of the antennas that are out there today, not only are they manufactured with really like old type technology, long screws and nuts and washers and all these other things, but like you said, you could pretty much use one hand and almost no tools, right? So literally, if you put that one bolt into the bracket, you climb up on the tower, you swing the thing around, it's really just one bolt is all you have to put in, and then ratchet it down. And then, of course, the radio interface, right? Our proprietary twist locking mechanism makes it really easy for connecting, disconnecting, and maintaining the RF interface into an antenna. So, there's just everything about it is just pure innovation, right? And really pushing the limits from what's been out there.
Right, like we were talking earlier with John about it. He said that the beauty of it is you put the horn up and you can change technologies with just a twist. It's really innovative.
Yeah. Again, thanks. It's another great point. We're vendor neutral as far as radio neutral, right? So yeah, today you might be happy with Ubiquiti, for whatever your reasons are. That's great. That's your network. But tomorrow you may say, hey, I want to try Cambium, or I want to try Microtech, whatever it is. Yeah, you just disconnect your radio, get a different twist port, and it's back on. You don't have to change antennas and technology and all this other stuff. So it makes it very easy to go back and forth and see what works for you. It's really about what works for you.
Right. And by the way, that first horn I put up for my network about a month and a half ago, unbelievable performance on the people that I've signed up on it. It just works. It works well. And there's no chain imbalance like you were talking about, no matter what channel I use.
Yeah, and not only is it again the changing of the frequency that whether you go in the Uni 1 or you're in the Uni 2 or Uni 3, where we know power levels change, so that changes your link budget and stuff like that. But really, those chain imbalances are one of the biggest factors that affect stability and high MCS rates, right? So when you have chain 0, at a higher intensity than chain 1 or vice versa, those modulation rates really start bouncing around because the radio gets confused. Not confused, but it really has to work to say, hey, what can I keep as a stable MCS rate? I have to shift down to make it happy, make the receiver happy at this point. Therefore, you get a lot of bouncing MCS rates. And there's another really unique property of the horn and what you get compared to sectors is the quality of the signal that you're putting out across your coverage area doesn't deviate as much as well. So you might have, in some cases with lower gain horns, you might have lower signals, right, on all your subs compared to what you had with a higher gain sector, right? But having a more stable, lower delta between the MCS rates of all your customer gives you an overall better experience, less latency, less jitter for voice and video. I mean, just all around, it's a balanced network is a happy network. You guys know that from from a throughput standpoint, but also from a modulation standpoint. It's extremely important, and we bring that to you.
Right. Dennis, were there any questions on the chat at all?
Oh, that's actually a really good question. Let me go check that. There was some comments about the Microtech exploit, but other than that, nothing really too much. We will put a call out for anybody who has questions. Go ahead and type it in at this time. I know we have a number of listeners online and such.
Tasos, you had put together a presentation. Do you want to segue into that, or do you have something else you want to mention?
Sure. I mean, we have time, I think. So let's just talk about some of the other products I had mentioned earlier. So our Ultra Horn is our new, larger horn for point-to-point, basically. That's what it was really developed for. And actually what we're seeing in the field is that more and more people are actually using our Ultra Horn for really high-density, very narrow beam point-to-multipoint, and it's really crushing it right now. We had an early on customer, I think with Cambium, did a 15-mile link with an EP&P 2000 on an Ultra Horn and was getting full MCS 1415 at 10 miles practically out in East Texas. The other interesting bit about that information is previous to that he had, I think, a 30 dB dish, right, is what the link was, and our 24 dB horn outperformed that. So not only was he getting full modulation over 15 miles on a 24 dB horn, the other thing was he was previously suffering from thermal inversion, thermal fade, right? So as the ground heats up and moisture starts boiling off of it, especially in the mornings and in the evenings when the temperature delta happens, your beam starts to refract, right? So you're basically, it's like your antennas go out of line or out of link. And he was constantly getting down modulated for an hour or two a day while things stabilized and brought things back in. Now, when he put the horn up, that problem went away. And the reason that it went away, I mean, his signal still got worse as the thermal inversion happened, but because of the huge SNR gains from the noise isolation of the horn, his SNR was large enough that even though he lost signal and SNR went down, the SNR was still high enough to maintain full modulation at 15 miles. So quite incredible. Our Ultra Dish product. So Ultra Dish is basically the same old parabolic dish antenna technology. as far as the general description of the product. Of course, our Ultra dish is much different than other parabolics. It's waveguide fed, again, with the twist port mechanism. And the way that the dish is designed, the uniformity of the dish really gives you balanced chains. So again, we have a 24 and a 27 dB version of this Ultra dish, and they're really starting to, again, outperform higher gain parabolic dish antennas. I think our 27 dB dish, which is our Ultra Dish 550, is in some cases performing at the same level or better than some of the LW30s and other type higher gain dishes that are out there. And again, the reason for this isn't that our gain is higher, but it's better, right? We have more balanced beams. Again, the chain to chain performance is making the radios more stable, therefore able to maintain higher modulation rates and transfer much more data, right? So our Ultra Dish product is fairly new. It's really groundbreaking, again, from the user experience as well, which is quite important from the performance standpoint. And then we have our PAF, right, which is basically our air fiber Prism twist port adapter. So for the people who use Prism radios, we had our Prism adapter, right, which is that really easy to click in radio interface. And then the air fiber came out, and the form factors and the mechanism is quite similar. So now we have a single adapter called the PAF, the Prism air fiber, which allows you to use only one adapter for both radios. So whether you're using Prism or air fiber, we have one adapter that handles both of those. Plus, it has an embedded pocket now to put your GPS antenna on the inside, so you protect it from angry birds that are trying to eat your little GPS cable. And also just protect it from the elements. So another great innovation from RF Elements, again, on new radio platforms. And we keep looking at more and more platforms as time goes on.
And those are products out and available for us to buy right now?
Absolutely. Those are 100% on the market. They've been on the market now for a few months now. So yeah, they're definitely available. And like I said, we have a huge roadmap of things in the future. So we continue to innovate while the rest of the market imitates, is what I like to say.
Well, even if you're old,
thinking of seeing folks lobbing stuff, the old Angry Birds game, trying to lob at your GPS antennas and stuff. That's really cool that you can bury that GPS antenna inside and get rid of that, so you got one less thing on the mast to worry about coming loose or getting damaged or what have. That's cool. Yeah.
That was one of the biggest things for us as well, because again, Prism and air fiber are two extremely popular radio platforms, and that was the problem. People were asking, hey, where do I mount this GPS antenna, right? Because again, we use high grade, high quality material. So we use usually non-ferrous materials, non-steel, because we don't like rust. So we have stainless steel hardware. We use a lot of aluminum and some other products. So typically, you're unable to take the GPS antenna and just stick it to some ferrous material that'll stick to. You have to find a pole or something on the tower in order to make that happen. So we decided to just tuck it on the inside, and that kind of takes care of that issue now.
Hey, I got a quick question if I can. I noticed that you guys I'm a big fan of the horns. I've been using them now for a couple of years. I probably have about 120 of them around the city now, and they work really great. I noticed now you have a Gen 2, and maybe I'm behind the times and staying up to date, but what's the difference between the original Gen 1s and the Gen 2 horns that are out there?
Yeah, so from a performance standpoint, they're practically the same. The gain is the same, the beams are the same. There's some slight RF improvements, mainly in like VSWR, again across the spectrum. The gain, I think, is just slightly flatter, but it's more of a user experience. So we had early on some issues with hail. Hail was the biggest problem. The radome that's on the front of the Gen 1 horn would crack in large hailstorms and stuff like that. Again, it wouldn't affect the performance of the antenna, but we had issues where you'd have to change the radome out. So we've now changed the radome to a more robust material, so therefore that's no longer an issue. We've also changed the mounting, the mount on the horn itself, so it makes it easier for you to switch from left to right side pole mount where with the Gen 1 horn, again, you can still do it, but it was a little bit more of a pain in the butt to kind of swap it around, and you had to switch the radome so the drain hole was on the bottom and stuff. So now the mount itself just actually flips and the horn doesn't have to turn. So those are some of the main improvements for Gen 2 over Gen 1. So it's the same groundbreaking performance, just a better user experience.
Rock on. Those are great changes.
Yeah, so I mean, we're very open. We listen. We love criticism, both good and bad, right? Actually, I appreciate the bad ones because that helps us innovate fixes to make things better, right? So most of the fixes that we implement are coming from users like you, right? You tell us what you don't like, and we just try and make it better, you know? So pretty simple.
Proactive.
There you go. I still do not have any other questions on our chat. So Tasos, if you want to go into your little PowerPoint, we can definitely do that.
Yeah.
Unless there's not something that you don't want to show.
No, absolutely. I can do that. Just give me 2 seconds here to get screens set up. 1 second and share the screen. There is at the end of the presentation, there's actually a video. I don't know how well that's going to play, but we'll address that when we get there. So let me just share my screen here. Let me know when you can see it, and I can go into it.
Yeah. Awesome. We have your presentation on the screen.
Excellent. So RF Elements, we build technology for fast, sustainable wireless. And we do this to allow you to grow smart, reject noise, and more importantly, save spectrum. That's really important today, because spectrum again is at a premium these days, and it's hard to find clean spectrum in order for you to operate. Even though the 5 gig spectrum is fairly large as far as real estate goes, finding actual usable spectrum is difficult, and our horn antenna technology gives you the ability to tap in and utilize as much of it as possible and be as efficient as possible. So let's start with a little background again for the viewers out there who may not know RF Elements and what we do. So just real simple, RF Elements as a company, we're based in Slovakia in Europe. The company was established in 2010, and our real main focus really is innovation. So we want innovation to be in everything from, again, the performance to the user experience. So that's our main focus in bringing innovative products, not building a better mousetrap, not trying to tweak previous designs. We want to bring totally new stuff to the market that's groundbreaking and really game changing. So back in October of 2014, I think it was one of our first WISPA-paloozas, RF Elements really changed the industry paradigm for how antenna technology works, or how it's used, and what's available on the market. A lot of people don't really know that our technology has really been around for a while, and the horn antenna technology that we kind of re-innovated and we brought back to life and we brought to this industry to kind of break the normal solutions that were coming out from the industry of more and more gain, really is something that is part of our core innovation and how we make things different than everybody else. And so we started seeing this trend, right? So there was a trend in demand for throughput, and this trend continues to grow almost exponentially. And there's really 2 parts of this trend and demand for throughput. Not only are we seeing the number of requested internet connections growing year over year, right? So the number of internet connections that we have to deliver as WISPs is growing exponentially. At the same time, the amount of bandwidth per connection is growing at the same exponential rate. So not only do we have to service more customers, but we have to give them better service and faster service. So we were looking at this and said, well, how can we do something different? What's really the problem here? What can we really do to address this issue of growing demand that's outside the norms of what everybody else was doing in the industry? So when we dove down and we looked at what was really happening, we saw that the challenge really was a lack of spectrum, right? So in order to cover the growing demand, we've seen new standards being introduced with higher theoretical speeds and more complex modulation rates. But, they all require more spectrum, right? So when spectrum is a challenge, and you have a radio that comes out and says, hey, we can deliver more speed, but you just need more spectrum to do it. 20 megahertz isn't good enough anymore. You need 40 or 60 or 80 megahertz of spectrum. And in some cases, I've seen 100 megahertz of spectrum. We realize that, this is going to be a very big challenge to address. So, spectrum is really limited due to the high amount of RF interference, right? So while we saw the wireless vendors bringing these advanced technologies and complex solutions like GPS synchronization, TDMA, active filtering, all these new kind of high dollar, high demanding type feature sets in their radios to address the issues, we realized that those results, the results of those are really not sufficient because none of those things were really addressing the lack of spectrum that was out there. And then we saw that really the problem was, again, RF pollution, noise, plain and simple, right? So RF pollution is caused by, nowadays an almost endless amount of RF noise created by poorly designed and irresponsibly deployed gear, right? So people using, really, leaky sectors and sectors that are too wide and sectors that aren't isolated or aren't shielded right and all this other stuff. And the RF noise, is really a result of signals that are traveling too far because people are using too much gain or in unintended directions with incorrect signal timing, right? So when you buy a 45 or a 60 degree sector, you expect it to pretty much cover 45 or 60 degrees. You're not expecting that thing to be able to bleed off the sides through side lobes to 90 degrees or even beyond that, right? So the RF noise is, really created by these poorly deployed designs and outdated gear in a real unsustainable way. So that was really the kind of the overlook, right? What we saw and said, this is what we have to address, right? So what we did, is RF Elements. We deliver fast, sustainable wireless, and our solution was done in basically a two-prong approach, right? So the first thing was noise rejection. We said we have to not only be able to reject noise, but we have to make sure that we don't put noise out there. So we created the horn antenna, the symmetrical horn antenna, and it's actually a very special horn, right? So people use the word horn antenna pretty freely these days. They say horns have been around forever, there's nothing new, and all these other kind of, types of explanations for horns and stuff. So we went with a very specific type of horns, and there's dozens of different horn profiles out there, but we went with the scalar horn, which is symmetrical. And the very unique properties of this type of antenna is high noise rejection and very, very balanced and highly precise radiation angle. So this is what addresses the noise for the issue of not hearing noise, but by being able to precisely project your beam pattern exactly where you want it and not bleed off. We solve the issue of the RF in unintended directions or with wrong signal timing. So the horn antenna was the first step. The second step, and something that is really quite overlooked these days, is our zero loss or near zero loss twist port ecosystem. This is really one of the biggest innovations that is often overlooked about what we've done to the industry. So by going to this waveguide fed interface for radios, really address the issues of making radios more efficient by not having as much loss transmitting the signal from your radio to your antenna. Also giving you the ability to create very clean signals at low loss. So when you combine the zero loss and the noise rejection of our horn antennas and our proprietary twist port mechanism, you finally get that massive scalability that the WISPs need today in order to grow and meet the demand for growing internet connections, not only in the number of connections, but also in the amount of bandwidth per connection. So let's look at kind of some antenna profiles here. So we call this noise generation. So here's a few different types of antennas that are out there currently on the market. So if we look at the top left sector here, this is basically an RF simulation of what the RF energy field looks like leaving an antenna. So on the top left-hand corner, I don't know if you can see my mouse, but up here, this is a very popular 19 dB, 90-degree sector, right? And when we can see, if we draw the lines, the red area represents where the signal is supposed to go. And in this particular sector, you can see it's practically an omni. Not only does it have these huge side lobes here on the side, on both sides, so basically it makes it almost almost a 180-degree sector. You also see this huge RF leakage out to the back. So this makes this antenna very poor for co-location as well, and it makes it very difficult to deliver signal where you want it to go. If we look right below that, we see here, this is that same, another 90-degree sector with an RF armor shield or RF kits or armor kits, things that people are spending extra money. You know, they buy a sector that doesn't perform well, and then they spend more money on some shielding to go on it. So this RF armor kits, this is what actually happens to your sector when you put an armor kit on. So not only do you still see these huge side lobes off the side, right? You definitely see a reduction in the RF out the back, so it does improve your co-location capabilities. But the most important thing, and the one thing that is overlooked, is how it affects the RF signal that's actually facing your customer. So this, by putting these aftermarket shields on your antennas, right, you're changing the electric properties or the RF properties of that sector you purchased. So basically, that spec sheet that comes with the sector you bought, just crumble that up and throw it in the garbage, because that's no longer relevant, right? So it changes the forward-facing RF properties of the antenna, therefore, again, giving you more massive chain imbalances, giving you unequal coverage patterns in both the horizontal and the vertical, right? So it really affects the most important part of your sector, and that's the one that faces your customer. If we look on the top right, this is, again, a very popular high gain sector that's out there. This is a 21 dB, 45-degree sector. So if we look at this simulation, again, the red indicates, roughly the 45-degree angle that it's supposed to serve. So you can still, again, see huge side lobes coming off the side, and you still see leakage out the back, right? So again, people think, well, we'll just make more narrow sectors, again, built on the same patch array technology, and higher gains, and that's going to give you more noise isolation. I mean, it does crunch the front, so it makes the beam more narrow, but again, it just accentuates all the side lobes and everything else that happens. And actually, in this particular one, you could even see it's kind of crooked, right? So it kind of turns to the left a little bit over there rather than coming out through the back. So you can imagine trying to plan your coverage area is very difficult. And then finally, on the bottom here, we're looking at a parabolic dish. And the reason I put this one up here, again, this is another point that's greatly overlooked. Everybody thinks that the main beam pattern is the only thing that's important. So this is a 29 dB parabolic dish antenna. And if you look at the spec sheets, right, typically 29, 30 dB parabolic has like an 8-degree wide main beam. And everybody thinks that this is like the pinnacle of noise isolation because it's a very narrow main beam, but they totally ignore, all the side lobes that come out. So, I mean, if you look at this thing has no more noise isolation at 8 degrees wide than this sector on top has at 45 degrees wide. So it's really ridiculous that these old technologies, keep getting pushed for more and more gain in the goal to seek isolation based on a spec sheet that has a narrow beam number, and therefore everybody has their blinders on and they totally neglect and ignore the side lobes, the other parts of the polar plot that still exist. So this is what your brain looks like on side lobes, I guess. So that's noise generation. This is noise rejection, right? So this is our horn antenna technology. So on the left, we're looking at our ultra horn, right? So our ultra horn has a 17 or 18 degree beam pattern, right? So you can see, again, it's highly focused. The beams are very, very uniform, and it's very clean. Of course, it goes wider, right, than the spec main beam, all antennas do. Antennas are not lightsabers. They don't just stop at that number. But the difference is how fast does the gain and the signal bleed off at the edge, right? So you can see that our ultra horn puts out a much cleaner signal, and in a lot of cases looks better than some parabolic dishes. If you look on the right here, this is our 30-degree horn. Again, if you look at the beam, you can see how beautiful it is, very balanced. It's very uniform in the way it propagates RF out from the waveguide interface. And again, it's much more elegant. There's practically zero leakage out the back, right? So it's a very clean antenna technology. It allows you to have very precise radiation angles and deliver your signal where you want it to go. So, you know, really no side lobes is what you want in antenna technology today.
So Tasos, I got a question for you.
Yeah.
So if you go back a slide to the standard antennas, I noticed that even with the RF shield kit, etc., and the 45-degree sector in the upper right corner, we actually get radiation out the back of the antennas and around the RF shield kits, things like that.
Correct.
On the 90, you get radiation out the back. What makes the horns not do that? Is it the material that's used, the design, etc.?
So it's a byproduct of the horn itself. So it's not just the material, it's just how it works, how it resonates. Because every time you add some sort of metal surface near your antenna, it interacts with the RF signal, right? So as you can see here, you almost create this kind of turbulent eddy here on the edge of where this shield kit is, right? So you can't just put metal around an RF antenna and say you're going to block it. So it has part to do in the inherent characteristics of the type of antenna, and horns are great for that isolation and not allowing the leakage out the back. Part of it has to do with the materials and also how the antenna is built. If you look on the inside, and actually if I can fast forward back here again, you can kind of see inside our horns, it's not smooth. It's not just a plain little step down like you see on other horns out there. There's actually frequency selective surfaces within the horn itself that help. It's kind of like noise canceling headphones, right? It kind of reflects back, you know, out of sync the same signal, and therefore canceling the ability for it to kind of leak outside the antenna. So basically we're able to keep this RF inside the metal structure, and it's not until it's outside the main orifice that it actually starts to propagate. So that's how, you know, how we get that. It's about the type of antenna. And if you look inside our ultra horn, again, you can see all these little slots that are in there. Again, those are frequency selective surfaces that allow the RF, once it gets excited in the waveguide chamber, it keeps it within the horn and makes it ride out so it doesn't bleed outside. So that's kind of the layman's term explanation for it.
Gotcha.
Does that make sense?
Yeah.
Okay.
That's like one of those, you know, we get all these, these sectors that they might have a metal backplate for irradiating the RF, but the physical sector is all plastic.
Correct. Yeah, I mean, again, just the metal backplate alone is not enough, right? We have a carrier class sector, so we have the carrier class antenna line, which is basically the same patch array sector that people are used to, that we actually have had on the market for like 7 or 8 years now. It's not until now that people see what our horns can do, and that they're saying, well, RF Elements knows what they're talking about, that they're now visiting kind of our technology that we've had on the market for 7 years. We have built-in shielding on the back of that as well, and it's not just a piece of metal, right? It's frequency selective surfaces, right, that help us form the beam. It helps us reduce some of the side lobes. We still have side lobes. It's still a patch array sector. You can't get away from that. It's inherent to the antenna technology. But our back shield helps us reduce the noise out the back, and it also helps us form the beam, as we'll see here in this next slide as we go into how patch antennas work or how sector antennas work. We don't suffer from all of the issues in our old antenna technology like people still are today. So if we look here, this is a patch array versus a horn. So this is a patch array sector, right? So if we look at it from both polarities, you have your horizontal beam and you have your vertical beam, right? This is the polarization I told you about earlier that doesn't match. So you can see how there's areas where the vertical or maybe horizontal is wider or more narrow, so you don't get a perfect beam pattern in both polarities. And then you have these huge side lobes that, side lobes don't just go out the side. Side lobes are anything other than the main beam. So they go off the top, the bottom, and the side or the back. And then you have that low performance area that we just saw, right? The low performance area is where the signal is the worst. If we look at customers deployed across this sector, usually the ones in the center get the best signal. They have the best chain performance. And as you move to the edge of the sector, performance starts to degrade. With a horn antenna, the horizontal and beam patterns are practically identical. So no matter where you are in the horn's coverage area, you're getting the same signal intensity and the same gain delivered to all your subscribers, right? So you get the best modulation rates or the most stable modulation rates in a horn coverage area versus a traditional sector because of all these, again, inherent flaws that are in the old antenna technology. And one of the biggest problems about this is, if we look at the radio technology of yesteryear from 10 years ago till now, when we went from, 802.11b to A, right? We went from, from the early modulation rates to OFDM, and we go, beyond from 802.11a to N to AC and AX, maybe even in the future, right? The radios require much better RF performance on both chains in order for these radios to really work. So while the radios have evolved over the years, the antenna technology never followed it, right? So the manufacturers took the easy route by pushing more gain in order to get you higher SNRs to try and mask the issues that were really there. And that's really the problems. Where we took the different approach, we went totally opposite and say, let's go to lower gain, because again, if you're using a lower gain, you'll see less noise as well. If you have a perfectly performing antenna in vertical and horizontal, you won't get those chain mismatches, and therefore you'll get more stable MCS rates and stuff like that. So this is some of the big, black and white differences behind the old antenna technology that was suitable 10 years ago, but is absolutely not suitable today. So let's look at like noise rejection here, right? So if we look at a traditional sector servicing some coverage area, right? You have, again, this sector, it's usually too wide, right? So as you start getting noise into the side lobes or in the low performance areas or where the coverage is too wide, it starts affecting your performance. Because horn antennas, again, have good noise rejection, you're not affected by noise as much. And because they have very precise radiation angles, as your coverage area grows or you need more density, you're able to co-locate more of them. So you're allowed to, again, deliver more bandwidth in your coverage area using noise rejection RF element horn antennas versus traditional sectors, because the sectors really don't let you scale and grow your network like horns do. If we look at that zero loss concept again, right? So basically, we removed the highest failure rate in radios, outdoor radios, is the pigtail connection where water ingress happens, right? So our zero loss concept is, let's get rid of this old technology, again, that worked, in 10 years ago, and let's go to this waveguide fed. So you have zero loss, and it's a more efficient way of delivering the radio signal from the radio into the antenna. And, not only is it a physical issue of water ingress causing issues, but in most cases you'll see anywhere between 1 and 3 dB of loss in a lot of the pigtails that are out there today. You take these low quality things that are made in China that people buy on eBay, pigtails. They sometimes have RF connectors that aren't spec'd for 5 gig or above. The LMR that they're using is low quality. If you're losing 3 dB of signal through your transmitting medium, a pigtail, it is half your power. Every 3 dB is half your power, right? So we totally eliminate that, and we brought this, again, groundbreaking game-changing innovation to the industry for the outdoor 5 gig market. So here are some of our twist port adapters. So the zero loss system is, the ability to actually take a radio that's not connectorized and make it waveguide fed. But the market is just saturated with all these connectorized small form factor radios, right? So if you're using Ubiquiti, if you're using Cambium, if you're using Microtech, or even Mimosa, we have twist port adapters that allow you to take this connectorized radio form factor and turn it into a waveguide fed adapter, right? So whether you're using EPMP 1000 or 2000, the Rocket Prism, the old Rocket M5, AC Light, Air Fiber, the C5C, the list goes on, and it's all on our website. No matter which radio platform you're using, all the popular ones, we have an adapter that allow you to tap into, again, our twist port ecosystem and use our near zero loss apparatus and connect to any of our twist port enabled antennas. So whether it's an ultra horn, a symmetrical horn, or an ultra dish, this adapter works on all of them. So one interface, all the antennas. So when we bring all that stuff together, you finally get that massive scalability that we were talking about, right? So again, if you look at the traditional sectors that are out there, you have co-located towers, co-located sectors. As you fire up another tower in another sector, those side lobes interact. You create a region of noise that makes the radios very difficult to operate in. And if you just switch to horn antennas, the more horns you put on your tower, the better the overall performance gets, because as long as you have an old sector on your tower, you're having side lobes, and the only way to really get the massive scalability is to use RF element horn antennas with very precise radiation angles, very high noise isolating characteristics, and therefore you'll get the massive scalability to deliver all the throughput that you need. So again, if we look at kind of the before and after, if you're using traditional sectors out there, you're always going to have noise, you're always going to have side lobes, and you're always going to be fighting these issues. With RF element symmetrical horn antennas and our antenna product line, we help eliminate that and allow you to maximize the delivered throughput. So this is how everything works and what we brought. So if you look at, again, the industry for antennas before RF elements, we had this, these disruptive companies come out there and create these really low cost antennas, and their innovation was cost disruption, right? But that cost disruption was really silly, right? Because what good is cost disruption if you make a low cost sector, and then in order for that sector to really kind of work, you have to spend the same amount of money, or if not even more, for an aftermarket shield kit to make it seem like it's better, right? So a cost disruptive product is really not the way to go. So you can see all these sectors with these, all these different shield kits that people are putting out, and a lot of these, aftermarket shield, not all, but a lot of the ones that are coming out, are probably not even engineered or tested in chambers and stuff to make sure that they're proper. You can't just make, again, a metal box, make it look like a cool shape and throw it behind a sector and expect it to perform. You have no idea what you're going to get. The only thing you'll see is, again, this kind of perceived co-location improvement, which happens because we saw in the animations or in the simulations how it reduces the leakage out the back, but it totally affects what's facing your customers, and that's the wrong way. So if we look at now, this is what we see. This is RF elements in the pinnacle and the ultimate for delivering throughput to your customers. The ability to highly co-locate multiple APs. Again, another thing is, this radio technology has changed, but we still haven't really been able to change the number of customers per AP, right? So you have to deliver more connections. You're getting faster speeds, but you're still stuck between like 15 and 30 subs per access point. That hasn't been improved. So the only way to get more customer density is to put up more APs, and RF element horn antennas give you the ability to stack up. It's moving. It keeps growing every day. But right now, it seems like the standard is like 12 horns on a tower, right? So, it keeps growing. I've seen and I've talked to WISP that have as many as 20 to 24 APs on one tower. Totally not doable with sectors. And with RF element horns, as you can see, it's definitely possible. So, That's me talking to you, right? Of course, people don't always trust or want to hear what the manufacturer has to say about their products. I mean, no manufacturer is going to come out and say, well, hey, our products suck, don't buy them, right? So of course we're going to talk good. So you want to hear from the actual customers themselves. I have a little video. It's like 5 minutes and then we're done. I don't know how it's going to work. I'll try it, but I'll preface this with, if for whatever reason the video doesn't work, go to our YouTube channel. We have a lot of customer testimonials. And again, don't listen to us. Listen to what your fellow brother and sister WISPs are saying about our antenna technology and how it's helped. So with that, I'll launch into this video, and I hope the video and the audio come through. So you let me know. Here we go.
The horns are pretty interesting when we first found them. Me and my partners looked at them and said, what the hell?
I seen what other companies were saying about the RF Elements horns, and I just had to have them. When we got them in, they performed exactly like what other people were saying.
So I said, okay, well, I'll give it a try. So, he was telling me to put it on the tower. So we put 3 on the tower. And overnight, all my problems were resolved. Nobody were having the issues they were having before with the latency issues or the slow bandwidth.
So we took just 2 or 3 horns and we put them in place of carrier sectors, and we actually had to triple check what was going on. We're like, something's not right here. This is not right, because the difference was literally night and day.
We put it on a tower that had another service provider on it, and noticed that the interference almost went away completely. So we were pretty excited about the performance, and since then we've put them on pretty much every tower that we've had. So in the last couple of years, we've put up real close to 2,000 RF element antennas.
The quality that the client's connections are compared to what they were a lot better on the horns than on the traditional antennas. So from an interference point of view, it definitely makes a huge difference.
We've replaced all of our panel antennas with the RF element horns. They're working absolutely wonderful. We've seen a reduction in support issues, and we've seen an improvement in basically quality of experience for our customer base.
We've seen better customer experiences. We've seen more stable connections. We've seen customer complaints go down.
Past what RFB actually gave us was the bleed through was gone. The true side-to-side interference, we didn't see it. So it was great there. It reduced our workload completely.
Might have a few customers, the area explodes, we need to add sectors, we need to add capacity. The horns are great for that. They allow us to pretty much ignore the RF problems around from other WISPs. They allow us to add capacity in a minimal space.
My experience for our team has been, we put the horns up everywhere we want to try it, and we're like, we're not taking it down. It just works.
We found fantastic performance. The wide number of access points that it has the ability to hook to is really beneficial for us, and the cost price point is excellent.
Pull down a number of sectors, replace them with 30 and 60 degree horns. They're great. They install quickly. They are replaced quickly.
All in all, we're of course very happy for the horn antennas. Otherwise, we wouldn't have gone all in.
Because we use the new RF Elements horn antennas, we actually opened up sort of a new market that we couldn't really cover before. And the main reason for that is the pure quality of the signal that we can get to the clients.
So since we've been deploying the horns on our towers, we've managed to increase business year on year, each year exponentially.
One thing that I have particularly enjoyed about the RF Elements group is the extraordinary responsiveness. When I have a question, I can send this team a question and I get it answered immediately. If I need stock, I can get stock. So I have particularly enjoyed working with the RF Elements people because I've never had a problem getting what I need.
Any time we hit a hurdle with, access point or bandwidth on an access point, and just throw up one. They're cheap, they're easy, and it's from what the hell is this to these are awesome. Wasn't a very long period.
So that's it. I hope that audio and the video went well. I guess we'll see. But I'll end the presentation here with just stay tuned, right? So RF Elements continues to again innovate in the industry, again create true unique innovations, that are first time for a lot of things, right? We're all over social media, right? So you can find us on YouTube, Facebook, LinkedIn, Google+, Twitter, you name it. We're there. So we're happy to interface with our customer base. You can send us messages and talk to us via email or on social media. And like I said, for those of you who are really interested in seeing some more information, our YouTube channel is really great. A lot of great videos and testimonials and how-tos on our YouTube channel. And of course, our website, rfelements.com, or even our forum, rfelab.com. So stay tuned. A lot of really cool stuff coming from RF Elements in the future.
There you go.
Well, that was a pretty cool presentation. I was noticing with the drones flyby, no down tilt on any of these antennas, right? Even a real tall tower. Do I not put down tilt on these things?
Yeah. So there's no generic yes/no answer, right? So it depends. In most cases, people are finding that you don't need it, right? So unless you're specifically trying to go a very short distance, you typically don't need it. Again, if you're using our lower gain ones, the vertical beam is much wider. So the close-in customers and the far-out customers usually get really good beam performance with very limited down tilt. So again, it really depends. We have a great link calculator on our website that you can go to, and you can go ahead and plot your customers out there. It's not a link planner, but it's just a link calculator, and you can see by employing 1, 2, 3, 4, or 10 degrees of down tilt what kind of signals you should expect based on your horn of choice and your CPE gain. So we have that information for you.
Just to jump in here, because I'm one of those customers that absolutely loves the RF Elements product, and like Scott Stace said in the video, the support from RF Elements is awesome. They're very prompt. One of the cool things that I also noticed when we started deploying them is that near in the null zone is a heck of a lot better than on any of the other antennas that we've used in the past. So I think that's another thing that really helps support the product and gets it out there.
Yeah, and again, that's kind of one of the benefits of having the larger vertical beams. I mean, a lot of people look at that and consider that the Achilles heel, right? That we're wasting energy up into the sky and what have you. But really, for areas that have a very diverse typology, mountains and hills and stuff like that, typically you're installing multiple sectors because you have that very flat main beam, and you have to use down tilt on one for the close-in customers, and the other sector has to be more flat for the further out customers. Again, because of our horn antenna technology and how well it works, you typically don't have to split that difference as much. So yeah, you get really good null zone coverage. And the most important thing that I'll mention, because even with traditional sectors, they have all these side lobes. Again, side lobes aren't just on the side. It's anything but the main beam. So they come off the top, they come off the bottom, and they're on the side. Typically, when you're closer into the tower on a traditional sector that doesn't have mechanical down tilt to address the close-in customers, you're connecting to a side lobe, and that's the crappiest connection you can have. And that's why you see all over on social media and people asking for help. They're like, my customer is only 1,000 feet from the tower, a mile from the tower. How come I'm seeing such poor performance? I have this huge signal intensity. I'm getting a neg 50 or something like this, but the modulation rates are all over the place. And that's because you're connecting to a side lobe. With a horn, it's nothing but main lobe connectivity, and therefore the best possible RF connection that you can have.
I think we talked about this earlier, the last show, that if you are on the margin of a side lobe on the RF elements, it will not connect, right?
No, it will. So again, everybody, not everybody, I say that in general term, and I apologize. A lot of people, think that antennas are, again, like lightsabers, like you turn it on and it just stops at a distance. RF bleeds off as things go, right? So the difference is with our horn antennas, the drop off of signal is much faster as you get to the edge than a traditional sector. So if you're out at distance, you go a couple miles from the tower, it almost looks like that. You can be outside of the coverage area and maybe not even see that AP, which is absolutely fantastic, right? But as you get closer to the tower, again, it's all physics, simple math, link budget. The gain is still there with, again, people using high gain CPEs at too short of a distance. You'll still see it. So again, the key here is that our signal drops off at the edge and bleeds off much faster than any other antenna technology out there for point to multi-point, period.
One of the last things I wanted to say too is that if you are on a tower where you're paying a premium like an American tower and you have a standard sector up there, you can triple your density in the footprint with the RF element stuff as opposed to the one sector. So that's something to take into consideration as you saw those videos of all the RF elements on those towers. You're paying a premium for that space on that tower, and you can get quite the additional density on the tower by using the smaller horn.
Yeah, absolutely.
Another point I'll throw in is in a metro area like Albuquerque, we've run into situations where building owners don't really want huge antennas on the top of their roofs, mostly for aesthetics reasons and image reasons. The cool thing with the RF elements horns, I mean, you're dealing with something that's about 8 inches or so in diameter. You're not going to see that 14 stories up, 12 stories up. It's going to be a fly speck. And so from an aesthetics perspective, it's easier to deal with. It's easier to sell the property manager. I mean, when I go to a property manager, I walk in with a 30-degree horn and I go, that's my sector antenna. And they're expecting me to walk in with, a 4-foot big panel like the cellular guys. And that's just like, here's my sector. That's what I'd like to put on your building. Can I please? And they're really happy with that. And then you got wind load calculations, all your mechanical engineering issues that you need to deal with. A lot of that goes away. So you're saving not only in the RF abilities, but you're also saving in how much material and time that it takes to build out a mount to put this antenna up, or to put 6 of them up, right? Because you don't have all that other mechanical engineering, structural engineering things that you need to do.
Yeah, it's definitely one of the benefits. I mean, again, as you saw in some of the deployment pictures that are out there, and there's tons all over social media, is you can get anywhere between 3 to maybe 4, depends on which sector we're comparing it to. Some are larger than others, but on average you get about 3 horns in the same footprint or the same mounting area as a single traditional sector. And then absolutely, the wind loading goes down tremendously with horns. Not only lightweight, but the cross section is really small, especially when you're considering, again, a lot of people who are running traditional sectors are using these shield kits, which are like big sails out there, right? So they're big wind catchers, and our RF element horns are not at all. So definitely two great benefits there: density and reducing your wind load. Absolutely.
Well, I've got 2 questions, and then I'm done.
Yeah.
Are people WISPs using these as client antennas as well, with the feed horn as your AP?
Yeah, so it's not extremely popular, but there are some, right? So there's nothing. So all right. So we've only fixed one part of the issue. We fixed the tower side issue, right? So now you can have good beam performance, precise radiation angles, but you still have all these really. If you look at the radiation patterns for the CPEs that are out there, they're far worse than any of the traditional sectors. So we've only fixed one end of the issue. There's nothing better than a horn-to-horn connection. There are only a handful of WISPs that I've talked to that have used the 30-degree horn as a CPE. Now, people say, again, they get focused on this narrow beam. 30 degrees too wide for a CPE. And really, maybe that's partially right. I'm not going to just say hands down they're wrong, because there's a case to explain that. But if you actually look at the polar plots for these CPE antennas that people are using, they're much wider than 30 degrees. So actually a 30-degree horn is much more narrow. But the thing to consider is the gain, right? So, a 30-degree horn to a 30-degree horn at 18 dB, and you're at 14 or 12, whatever the 18 dB for TX power, you're talking 2 to 3 miles max, right? So if you're running a really small cell site where your radius is 2 to 3 miles, a 30-degree horn would pretty much rock it for sure. It would rock that installation, absolutely, because then you'd be getting the perfect beam performance on both radios, and that's the ultimate solution.
Well, Dennis, do you have any further questions, or were there any questions on the chat?
Nope. We are all good.
Well, Tasos, you're going to be at Wispapalooza, I'm sure.
Oh, absolutely. I'm going to be there in all my horniness. Trust me, I will be out there. And like I said, it's going to be a very, very, very good Wispapalooza this year. Like I said, a lot of new stuff to talk about. So we're excited, right? I'm personally excited. I thought I was the only one that was as passionate, as animated as I am, and clearly it's not just me. John is just as animated and passionate about what he talks about as well. But yeah, we're going to be there, booth number 125. So again, if you want to see what real innovation is and not imitation like you're seeing from a lot of the other manufacturers out there, come to booth 125. Come talk to me and my team. We'll be happy to meet each and every one of you. I'm looking forward to it, man. I can't wait.
Well, I did lie. I have one last question, and you don't have to answer this. Will there be any new product announcements from RF Elements at the show?
You had to ask. So yeah, no comment, right? So again, we have a very long roadmap. Just because you don't see it now doesn't mean it won't come in the future. Just because you don't see it now doesn't mean we haven't thought of it. I mean, we've jumped on the horn antenna technology way before everybody else. So we've been innovating since day one, right? So just think of it as Area 51, right? The new fighter jet that you see today, is nothing compared to what they're actually developing today, right? So stay tuned. We're just starting to get horny.
All right. Well, thanks a lot, John and Tasos. We appreciate you guys being on the show, and look forward to seeing you at Wispapalooza. Dennis, you want to wrap us out?
Yep.
Thanks, guys.
Thank you.
Thank you for listening to ISP Radio. We hope you've gained new insights and additional wisdom in our industry as well as your business. Please remember to visit our show sponsors via the links on ispradio.com. If you're interested in becoming a show sponsor, contact us at sales@ispradio.com. Now go out there and push those packets as fast as you can. Good luck and Godspeed.